Science Beetle.
Hey, welcome back, students. In this video, I want to go ahead and walk you through the process of how you actually create a NFPA label. Now, what you see here on the screen is the SDS for sodium hydroxide. So you can verify that name here in section 1. And you'll see that here's the actual name. You can see sodium hydroxide. We are in section 1. And so remember from a previous video where I had gone over the more important sections of the SDS, we had indicated that there were 16 total sections. And let me bring this section up here so you can see it. Let's move this over to the side. And so here are the actual sections. And the idea was that if we paid attention to these 16 sections, there were going to be about 5 of them that were really important at helping you identify hazards fairly quickly. Now, these aren't the only 5 that will help you find the hazards, but these are the 5 that you want to start with first so that you can get the hazards identified a little bit more readily, a lot easier. And then if you need to, you go into the other sections and get some additional pieces of information to help you piece the puzzle together. The main sections that we want to look at are sections 2, 5, 6, 8, and 10. And so those are the ones we want to go ahead and look at here. Let's take a look at these sections and let's take a look at each section individually. You always want to begin by looking and verifying section that you've got at the very beginning, which is section 1. You want to make sure that you've got the right substance. So we are going to be doing the one for sodium hydroxide. So this is definitely the right one. So if we proceed on to section 2, this is what we'll see here. So in section 2, we see that these are the hazards identification, and we start looking for a lot of the special codes or any code that might help us identify hazards. Now, we look at the hazard class section and notice here that there's skin corrosion or irritation, causes severe skin burns and eye damage. And let me just move this over a little bit here. And we can see also that you're not to breathe this either in the mist, vapors, or spray form. The class hazard or the hazard class here is corrosive to metals, maybe corrosive to metals. Now, if we look at those special hazards, one of the main things that we're going to be looking for here are any of the special codes. So let's move this aside and bring up some of these special codes over here. I'm going to move a lot of these items out of the way so we can actually see it. And so here are the codes at the bottom. And you can see that the code that we're looking for here is the corrosive. And notice the code for that is COR. Now, where do we get that inside section 2? So if we look at section 2 one more time, you're going to notice that corrosion actually shows up quite a bit of times in here. So you'll see it right here. You'll see it right here, right here. And so that's actually pretty important for us. So when we go through and write down the code for this, we're going to make sure that we write that down in the special hazards section. So let's go ahead and move this over. I'm going to create a label down below. Let's move this a little bit and let's go ahead and put that code right here. I'm going to put it right here behind us. I'm just going to do the X for us here. Remember, the special code goes on the bottom, so we're going to write COR. And let's go and look at any other codes that are health related. So we'll come back over here. And so I might need to move this a little bit. Just bring this down over here. All right. And so we'll come back over here to the codes, section 2. Now, the one thing that you do notice here is that it causes severe skin burns and eye damage. Now, remember there's 4 levels. 4 is the highest, 0 is the lowest, and we got to decide where we're going to place this. So the way you'll do this is you go back to that scaling that we had from before. Bring this over here. I know we're moving back and forth through a lot of these items here, but this is the one that we want here. And we're only going to focus on the health for a second. So if you look at the health, having severe skin burns, that's pretty serious. But remember, the code actually starts at 0. If there is no hazard, then we wanted to give it a 0. But obviously, if we're talking about severe skin burns, that's not going to be a 0 rating. In fact, it's not even going to be a minor irritation here, so it won't even be a 1. Causes temporary incapacity or injury. That's almost getting there, but it's not quite there. Now, when we look at the word serious damage here in section 2, we got to pair it up with what we actually see in the codes. So when we look at this here, It causes severe burns and eye damage. That's actually a very serious thing. And so when we look over here for the placing or the equivalent on the scale, we look for the keyword. Notice here we've got the keyword serious. So I'm leaning towards 3 here. Now, the code doesn't say anything about lethality or being very lethal to you. So we don't have enough data to tell us that it's a 4, but there is enough data to support a rating of 3. So when we go ahead and rate this, we're going to go and put this rating at 3 here. So I'm going to go ahead and put in for the health, I'm going to put it 3. I'm just going to go ahead and color code it just so that we have a little bit of a connection to that rating. Okay, so that's the health hazard. We're going to give it a 3. Okay, now let's go look at some others. We're going to go look now at the flammability. Flammability is identified in section 5. And so section 5 is useful for the flammability. It also gives us a little bit of another piece of information that could be useful. And so we want to make sure that we get that identified. So in section 5, notice here is the firefighting measures. Notice here it says it's non-combustible. It may react violently with water, but this is going to be in the molten sodium hydroxide. Okay. There's a lot of contact with aluminum, tin, zinc liberates hydrogen gas. And there's a couple of other items over here. When heated to decomposition, it may emit toxic fumes. So all of that's pretty dangerous. But the main thing here is for fire is that it's not going to be combustible. So if we go look at the ratings on the fire schedule, let's move this over, bring this back over here. Notice here, we're going to see that in the fire, it's the red category. Not combustible. Now, if it were a rating of 4, the substance would be readily burning at normal temperatures. None of that was identified in section 5. The same thing over here. It's not going to ignite under almost all ambient temperatures. In fact, what section 5 actually said was that it's not combustible. That actually is over here, that it's not going to burn. So the rating that we're looking for is a 0. Okay, so let's go ahead and give that rating. And let's go ahead and put that in red. And so that rating here is going to be 0. Now let's turn our attention to the yellow category. And yellow talks about reactivity. So let's turn our attention back over here. You want to go ahead and look at section 10 for that. And so in section 10, we zoom in here, we can see that contact with aluminum, tin, zinc liberates hydrogen gas. You want to go ahead and avoid with contact with strong oxidizers, strong acids, organic material, chlorinated solvents. And in terms of the shelf life, how long can you keep it on the shelf? Well, it's going to be a good amount of shelf life that it's going to have. Now, what does that really mean? Well, the reactivity section can also refer to how it reacts with other chemicals. And so that is partially addressed here, but it also tells you whether it's very stable. And in this particular case, if something is extremely well at having a long shelf life and it's very stable, it's not going to have a rating of good. It's actually going to have a rating of excellent or indefinite. But the fact that it says good doesn't give it the best rating that it can possibly have overall. Notice also in the contact with all these other compounds here or elements, it does react and it does produce hydrogen gas. And so it also says to avoid contact with some of these other types of compounds. And so that alone tells you that there is a little bit of reactivity. So let's kind of see where it actually lies overall in the rating. So if we move this over to the side here, we're going to see, if we bring this over, we're going to look at the yellow section now. Let me move this a little bit up so we can see it better. And so now here in the yellow section, we're going to be looking at stable is not it. Although it does say that it's really good, it's almost there. It doesn't say anything about exploding, so we can go ahead and rule out number 4. It's not number 4. May explode at high temperatures. Well, again, section 10 doesn't say anything about high temperatures, so we can ignore and eliminate 3. It doesn't say anything about violent chemical changes at high temperatures, so we can eliminate 2 as well for those reasons. But it does say that it's actually it has a very good shelf life. And so that means that here it's normally stable. That actually is consistent with that statement. Now, it doesn't mention anything about high temperatures. So we can't really use the second part of the yellow code, but we can use that first part, normally stable. And because of that, we need to make sure that we kind of consider 1 for it. Now, if we go back to this rating on 10, notice all these items that it is cautioning us to be aware of. Avoid contact. Because there are mentioning here that there's avoidance issues that you need to take into account with this particular chemical, that definitely is not going to allow us to stay with the rating of 0. So we can eliminate 0 from that, and so our best rating here that we can achieve, given the data given to us in section 10, is going to be a rating of 1. And so if we go ahead and do that, move this over, let's go ahead and give that rating down below. And so that rating would be a rating of 1. Now, notice here in this section, the rating that we're ultimately going to give this particular chemical, sodium hydroxide, and let's go ahead and write the name at the very top here. And so that gives us the final rating of 301, and we put the special code of COR for corrosive down here at the bottom. This will be the rating for sodium hydroxide. Now, if you were attentive during this video, you would have seen a code given to you during one of the sections here on the SDS that I showed you. So let me just move this stuff down here to the bottom to get it out of the way. And let me show you what I'm referring to. So let's bring this sheet over here. And you can see here, particularly on section 5. I'm going to move this here so you can see it carefully. And take a look at this. Section 5, in some cases, if you go all the way to the right side, notice it has the NFPA code here. H is for health, F is for fire, R is for reactivity. So although we went through it the long way and identified the codes for health, fire, and reactivity, some of the SDS that you are provided actually does have the codes already laid out for you for easy reference. Now, this doesn't happen all the time, but in this particular case for sodium hydroxide, it was provided. So that essentially is going to be the way that you go ahead and identify the codes for sodium hydroxide. You want to go ahead and repeat this process for every other chemical that you encounter. You want to make sure that you have that at your disposal and build the skill so that at the very end of the day, you know how to generate your very own NFPA label for any chemical or element that is presented in class for you to use. You definitely want to go ahead and get these done before a lab, so part of the pre-lab requirements, or these might also show up also on quizzes and exams. So having these skills is readily handy for you, so you want to make sure that you take care of that. Okay, so if you haven't already done so, go ahead and subscribe, keep watching, keep learning, and we'll see you in the next video.